Here you're going to learn some techniques that are used in paleolimnological studies. That's a big word. What is paleolimnology? That is the study of lake histories and using lake sediments to understand the past. We can understand different aspects of both the biology of the lake as well as the physical characteristics of the lake and the surrounding watershed based on what we find in lake sediments. In this video, we have a guest visitor, Haley, from the University of Minnesota. She is a graduate student there who's using paleolimnology to study lake history in lakes across the state of Minnesota. She's going to introduce us to the concept of coring and the different types of equipment that are used. There are many different types of corers that can be used in paleolimnology. Some of them are very big and very complicated to set up, but the one she's using is quite simple. It's called a gravity corer. And so here is Haley, who will show us how to use this equipment.
So we're going to take a sediment core, and in order to do that, we need some sort of coring device. This is a HTH gravity core. Ours is a Swedish model, so we tend to call it the Swedish core. But this works by gravity. So these three things right here are weights that when I attach a sediment tube to, I'll be able to push down into the sediment just via the force of gravity. And that's how it gets its name as a gravity core. So you can set this up a few ways. So this is the core itself, and on it there are little ear flaps, and these ear flaps go inside little ear flaps on the coring device itself. So it looks like this. It takes a little love. And then once it's in, you spin it so that you can trap it. And now our core tube is locked in. So just by the force of gravity, we'll push this down into the sediment. We'll let it sit. But you have to ask yourself, how will the sediment stay in? So if you've ever had a milkshake, you've drank up the milkshake and you plugged it with your thumb, and it was just that pressure that keeps the sediment in. So we can do that same thing with this. This will sit open until I tell it to snap shut, and I'll tell it to snap shut once we're in the sediment. And so that's how the sediment will stay within this core tube. Now the next tricky part is, now that we have the sediment in here, we can pull it up, but as we pull it up, sediment's going to start to fall out the bottom. And it's especially bad when it gets to the air-water interface. So we have to find a way to plug the core, and we'll do that with a piston. So this piston will sit in the bottom of the core, and now theoretically, if we had mud in here, we would have a preserved sediment core. And we can use those cores for a couple different things. We can use them to ask questions like how much phosphorus is sitting in the top of the sediment, what microorganisms might live there, and then you can also do them to ask paleolimnological questions. So we can take cores much longer than this, think like 4 times this size. We can go back in time essentially by dating them using isotopes, and then we can learn more about the watershed. So we can say maybe we see a change in the amount of phosphorus back in the 1950s, and we might associate that with agricultural boom in the area and things like that. So sediment cores serve as sort of paleo proxies like pollen or ice cores, but they serve for where we live in Minnesota. Okay. So naturally, we wouldn't be standing on a dock. One place you want to take a sediment core typically, especially if you're interested in paleolimnological studies, is the deepest part of the lake. And that's because we want to focus on areas where sediment doesn't focus. So at the deepest point, all the sediment is coming down and it's landing there. So you're not going to be taking a core into the side of the sediment. And this way you have theoretically preserved layers of sediment year after year after year. And one way to know how deep the lake is, if you have a nice fishing boat, you might have a depth finder, so you could use that. But we tend to use these things called Secchi discs, and they serve 2 purposes. So you might be familiar with these for measuring things like transparency. And I'm assuming you've talked about transparency.
Yes, we have.
So you could put it in and you could say, well, how far down can I see it? But we can also just keep letting this go down and down and down until it hits the bottom of the lake. We can measure it. And now I know that this spot is roughly 1 meter deep. So if I were using a different type of core, I would have to do some fancy math. But since I'm just using a gravity core, I'm going to release it all the way down until I can feel the pressure of this core tube hitting the sediment. So I'll get this set up just like we had it set up before. So the first thing we want to do is actually we want to take our piston. If I was working with a partner, I might have my partner do this part, and as I pulled up the cord they would plug it, but I can't do that right now, so I'm just gonna have to do it myself. And I have this nice, what looks sort of like a beer stein apparatus that allows me to put the piston in without having to hold it. So I'll put that in there and hopefully it will work. So we need to unplug our straw, and then we're just gonna lower this down until we feel it hit the sediment. So I felt it hit the sediment, I pulled up. If you could see, you'd see all sorts of methane bubbles coming up from when I hit it. And now if I'm quick enough, we'll get a core.
Right.
And like I said, this is really soft, so it didn't do what it would normally do when you're out deeper in the water. But if we give this a few minutes, it'll likely settle, and we'll probably have captured maybe 8 centimeters of mud.
Now the next thing you want to do once you've collected your sediment core is to section it into slices. And this can be done either on site or in a laboratory setting, depending on the type of core that you've used to collect your sediment. And the reason you section it is to basically look at different layers of sediment and look for different characteristics of that sediment. And as Haley mentioned, you can date the sediment using radioisotopes to understand exactly what time period that layer of sediment corresponds to. And as Haley mentioned, we use different proxies as indicators for lake conditions historically and watershed conditions as well. So you could look at, for example, changes in the diatom communities over time that would indicate differences in nutrient levels in the lakes. Different species of diatoms thrive in different water quality conditions, and so we can sometimes link increases in phosphorus levels in lakes to European settlement or the onset of industrial agricultural practices. Diatoms are excellent paleoproxies because they are preserved in lake sediments. They're made of silica, and the silica does not break down over time, and you can identify them to species based on the shape of their silica coating. Pollen is also a very commonly used paleoproxy. We can look at changes in the plant communities in the surrounding watersheds and even understand fire history based on changes in the species of plants that are surviving at different time periods. Those that are fire tolerant may be shedding their pollen during a period where there is fire as part of the natural disturbance regime in a watershed, whereas the pollen will be different in a different layer of sediment when fire was not a common disturbance in the watershed. So pollen in lake sediments is actually useful for understanding past climate change as related to differences in the fire regime in watersheds, that you would expect to see more fire during a warmer, drier period than in a cooler, wetter period. And lastly, we can use invertebrate remains in lake sediments. Specifically, I use Chaeoborus, the phantom midge, as an indicator of historic fish absence in lakes. We can actually use invertebrates as paleoproxies for changes in fish communities. So lots of different questions that can be asked using paleolimnology, and it's a really fun tool. It's almost like being a detective. It's quite interesting.